Hello, today we are going to do a corrosion service, corrosion inspection in a boat is an Sea Ray Sundancer 55 feet. We are going to do the analysis step by step to identify where is the focus of the problem. In this boat, this is a wonderful boat in great condition. We found a lot of corrosion in the block of the engine, in the generator, in the sea strainers, the fuel filters. A lot of metallic brackets internally in the boat are corroded. But additionally, we found a problem in the ground, in the wiring of the AC system. Okay, for this analysis, we are going to use three tools. We are going to use the multimeter. In this particular case, I am going to use this Fluke multimeter. We are going to use the Sure Test. Ideal Sure Test is a great tool. I love this tool. And I am going to use the silver chlorine electrode. We are going to suspend the silver chlorine electrode in the water, and we are going to analyze what happened with those readings, the readings of a potential differential, to verify if the bonding system, the grounding system in the boat is in good or no good condition. Okay, we are going to start analyzing the pedestal. Yes, we check the pedestal. The pedestal for this boat supply power for two boats. For our particular boat, the shore power cable is the Y one. We touch the cable. We verify if the temperature, the ambient temperature is normal or if it's too hot. In this particular case, the cable is good, is in good condition. We touch with my fingers the breaker corresponding to the outlet. And it's good, the temperature is good, indicating that we don't have a short in that particular area in the pedestal. And now we analyze the voltage, the reading of volts in the outlet of the pedestal. And we check three readings. The reading between hot and neutral. The reading between hot and neutral was 118.4. Okay. The reading between hot and ground, 115.1. You remember in previous classes I explained that if the difference between hot and neutral in comparison with the reading in between hot and ground is more than 2 volts, this is an indication that the ground of that pedestal is not good, is contaminated. Through the ground of the pedestal is entering in the boat a small current or big current. In this particular case, the difference is around 2.6, 2.7 volts. The difference between a 118.4 minus 115.1 is pretty close to 3 volts, the difference. This is not good. It's not catastrophic in this particular case, but it's not good. Alright. Number one, we found the ground in the pedestal a little contaminated. Okay, we are going to enter in the boat and we are going to do different analysis. Number one, we are going to connect the silver chlorine electrode. Danny is introducing the silver chlorine electrode. The idea is that the electrode be suspended in the water, not touching the boat, not touching the ground. And the other end of the electrode should be connected in the negative terminal of the multimeter. In the positive terminal, we are going to connect our positive cable, and with this one we are going to touch the element that we wanted. The bonding, the block of the engine, the block of the generator, the sweet strainer, the element that we want to check if it's properly bonded will be touched with this end. It's simple. And we are going to verify if the readings are in those parameters. If the reading is more than minus 0.7, indicate non-protection. That element is non-protected. Later I'm going to explain what happened. If the reading is in between minus 0.7 and minus 0.8, inadequate protection. It's protected, but it's not perfect. If the reading is in minus 0.8 and minus 0.95, it's good. It's adequate. Good protection. If it's in between minus 0.95 and minus 1.05, no good protection. Bad protection. If the reading is more negative than a minus 1.05, is overprotected. And you remember, the consequence is that the pane is filled, is delaminated. That's not good. Okay, we are going to check some readings internally in the boat. Okay, we are going to start in the point, in one of the critical points. Is the bonding conductor, the main bonding conductor. We are going to check the reading in between the main bonding conductor and the electrode outside. And the reading in that particular case is minus 0.96. As you can see with the table, is out of the range. Not too much, but is out of the range. What is the meaning of that? We start in the bonding conductor, the main bonding conductor is not good. Alright, let me check, for example, the generator. The generator is the housing. The sun chill of the generator is minus 0.93. Okay, it's in the range. It's acceptable. Let me check the fuel filter. The Raycor Parker, the fuel filter, is minus 0.3. What is the meaning of that? That fuel filter, and exactly the same with the filter of the other engine, is not protected, is not bonded. For that reason, the pane in the cap of the filter and the body of the filter start the corrosion. You see the corrosion in both sides? It's not protected. Alright, we are going to check one point, critical point. It's the point where the bonding conductor is connected with the bolt that pass through the transom attached to the sink outside. In that bolt, we are going to check the connection, and is minus 1.03. This is the critical point, and is minus 1.03 is not protected according with the table. Okay, that's not good. We are going to check the block of the port engine, minus 1.08. No good. Out of the range. The heat exchanger, minus 1.177. No good. Alright, the motor mounts, the engine motor mounts, minus 1.163. No good. Look at this. The frame where the air condition is located is minus 0.968. It's out of the range. The intercooler on top of the engine, port engine, minus 0.98. The readings in the other engine are pretty similar. Alright. Conclusion. The test with the silver chlorine electrode no pass. The majority of the elements are out of the range, and some of them not protected. We need check the bonding, check the connection in between the bonding and the external sacrificial anodes, replace the majority of those wires, replace the majority of those terminals in those cables, verify the sacrificial anode externally, the condition. Other situation that we need to verify is if the ground bus bar in the AC panel is connected to the bonding, and also the negative bus bar in the DC panel should be connected to the bonding. We are going to verify later in other video if those bars are connected. If not, we are going to connect. Okay, in this moment we have 2 points, no good. The pedestal, the ground, no good. Internally, the readings with the silver chloride electrode, no pass. 95% of the readings are out of the range. No good protection, no good bonding. Alright, now we are going to enter inside on the cabin, and we are going to use the sure test. The sure test is magic, as you can see in other of my videos. I explain how to use the sure test because the sure test help to verify if you have a good connection, no reverse polarity. You can verify the current that is flowing through the wiring, and you can verify the condition of the cable of the hot, the cable of the neutral, and the cable of the ground. Verify if those wires, those cables are properly connected, and if those cables are not open or not in short. Okay, number one is we enter and we check the AC panel. This boat is a great boat, have a digital AC panel and the breakers. In the digital AC panel, and you can see, we have a red indicator in the area of the refrigerator and the cockpit. Probably we have a short over there, or something is wrong, probably in the outlets of that area. When you have that situation, you need isolate the problem. You need to try to verify if that problem was created because somebody installed in one outlet in that area an equipment with a problem, with short. In that case, if you reset the outlet, you eliminate the problem. In this boat, because this is a great boat, it's a good design, good wiring, close to the digital AC panel, they have a monitor to indicate that the power is entering good. It's in green color. And we have in the bottom of that monitor other green indicator indicating that the power entering in the isolator transformer and passing in the other side to the panel, entering input and output good. No reverse polarity. The green color indicates that the power is entering good. We don't have red light activated. If the red light is activated, probably you have reverse polarity. In that particular case, no. This is a good indication. I forget to mention something. We check in the engine room. You remember we enter and we check that bucket, white bucket in the bottom is where the short power cable is collected. That big breaker on the left side is the main breaker after when the short power enter in the boat. This is the main breaker. But around that area and around the bonding conductor in the transom, we check carefully, and we never found a galvanic isolator installed. We passed more than 2 hours checking all the corners of the boat and no galvanic isolator. This is not good. This is one of the jobs. We are going to install a good galvanic isolator. Alright guys, return to the AC panel. We have good input, the power is good, but we have a problem in the cockpit area close to the refrigerator. Okay, I am going to use the sure test in an outlet located pretty close to the refrigerator and the outlet located pretty close to the cockpit. And after that, we are going to check other outlet in the saloon and other outlet in the master room. In all of them, I found it a short to ground. Look at this. When I check with the sure test the outlet close to the refrigerator, we found that the voltage 118 volts. We have that the voltage drop is good, is acceptable. The current is good. We check the 3 lines, hot, neutral, and ground solid, all of them, indicating that they are okay. We check now the particular analysis of resistance in each cable. In the hot line, is good. Is good. We are going to check resistance. Remember, in my book of marine corrosion, the reading should be no more than 1.2 ohms. No more than 1.2 ohms. Okay, the reading in hot is good, is acceptable. The reading in a neutral is great, is good. But look at this. When I try to check the reading of ohms in the ground line, the breakers pop, and no power in the outlet and no power in the sure test. When I check hot, good, neutral, good. When I try to test the ground, the breaker pops. And finito. We did the same exercise in other outlet in the saloon. And once again, voltage good, everything is good, the voltage drop is acceptable, everything is good. Now we are going to test the hot, good. The neutral, good. When I try to test the ground, the breaker pops and the power is interrupted in the outlet. I did the same in other outlet in the master room. Hot good, neutral good, and ground pops. Alright guys, finito. We have a short to ground. What happens when you have a short to ground? One constant voltage is leaking, is flowing through the ground, and the ground is connected with the bonding and the bonding with the sink. Okay. All the elements connected to the bonding conductors will be affected for that short to ground. When you have a short to ground, it's a current that is flowing constantly through the ground. That's not good. The elements connected to the ground to drain static electricity are receiving current. The current entering in those elements accelerate the corrosion in between the similar metals. And this is the consequence that we have in the engine room. Conclusion. We need, number 1, install a galvanic isolator. Number 2, change the majority of the wires connected today in between the bonding conductor and the sacrificial anodes. All of them are corroded, highly corroded. Number 3, identify where is the short. What is the equipment that is producing that short in the ground? This is the next part. This is the next coming video. Today, according with the report that I feel, the system no pass. In this particular case, we have a bad silver chloride electrode test, bad sure test, and a bad ground. This is the process to analyze corrosion in a boat. Number 1 is identify where, and number 2, try to fix it. In the next coming episode, I am going to explain the process to install the galvanic isolator, where it should be installed, the process to replace all of those wires with the proper connectors, marine grade connector with heat shrink, and the process to analyze internally in the cabin what is the equipment that is leaking, leaking constantly current in the ground. Okay guys, I hope you enjoyed this episode.